All right, so now let's start our data structures class today. And in fact, well, today we will talk about structures, right? So that's why I put a structure of table salt, because table salt is at NaCl, right? NaCl, right? So yeah. So in fact, yeah, there is some relation to our data structures also implementation. As you can see, the atoms here are different size, right? And that's actually the we'll see when we deal with storing our data in structures also, it might have some applicability of how much space we take actually in our data structures in C++, right? So yeah, but again, so data structures in C++ of course are for what? For grouping related data. That's the basic big idea. They come from C language actually, and not very, well, they might seem simple, but actually it turns out they're actually exactly as powerful as classes in C++. Again, those who used C language structures, actually the C++ structures are basically, you could think of them as publicly available class definitions. You know, very rough overview, right? Okay, so we learn about structures. And of course, we'll learn about how to manipulate data, explore relationships data, examine the difference between arrays and structures, which seems somehow obvious to me, but well, right. And also we'll want to do how do we pass structures to some other functions, how do we pass them for usage. Okay, but let's look at the definition. Right, so structure is a collection of fixed number of components, right, where we get them individual components by name, right? So you come up with a cool name, right? Of course, use camel case, right? Structure name, and you have your data types, right? And so basically, this is just a template, right? You don't have data yet, right? You're just a template. Again, think of it as those who have used OOP already. We think of it as open as a class definition, very similar in C++, right? In C, this would be very, very basic, but in C++, actually, this is just the beginning. Okay, and again, sometimes records is used in some literature. I don't really particularly like this. I'm not, but you can use it if you want. So it's a definition, like I said, not a right. You say right. You need, of course, then use it, right? You declare it. So let's take a look at a simple example. I'm going to open up our code space here, right, or repository, and I'm going to open up our cuddly space spork, I think. Let's see if it loads up. Yeah. All right. So I guess I should probably organize some folders in a moment, but for now, so we'll do structs, right? Oh no, what happened? Why am I rename? Hello, rename struct CPP, right? So let's look at some. No, I don't want Copilot here. I want my own code. I'll take this, okay? No, not Copilot. Right. Oh, agreed. Good morning. Good morning, I should say, right? So that means Peteris, right?
Yes.
Yes, okay. Peteris gets from 0 to 1. From 0 to hero, right? Yeah, so yeah. Okay, you got the 1. Good timing, excellent timing. So, structures, let's explore some basics of structures. Yes, all right, so structures are user-defined data types. Again, so this now you get to, now you finally get to make your own data types. So we'll start with something simple. Of course, we'll include IOStream because we want to output something and using a namespace. Well, I guess string too, but not maybe, right? Yes. Now, oh yes, I want to do that. Come on. Let's start. Let's start with a simple point data structure, right? So point data type. So what does the point have? Again, assuming how many dimensions. So let's start with 2 dimensions, right? Well, we could think of it also as a single line, 1 dimension, right? For now, yeah. maybe more dimensions, right? Okay, so a point outside the main, typically, right? So, yeah, typically also define header files later about those. Yes, on capital letter. Good question actually. I guess so, but not required. But not required. Right. So, camel case, yes, of course. That's also again not required. Again, this means, of course, that this is actually your type, right? Size T, for example, right? And what else? S or S stub, maybe S stub actually, or right. Again, this is actually for type. You typically actually this is a T. Actually, T is typically actually for type def, right? Not struct, right? So this actually AI is a little bit, of course, hallucinating a little bit right here. Don't trust everything, right? Trust but verify, right? Yeah. Okay. And now, of course, finally we get to our structure file. Struct, right? Struct point. Come on, I'm too lazy. Right. Now AI is getting too much. Okay, I just want a simple point. So what's a simple point? I say, okay, remember the structure, right? And of course, I don't want this, all of this here. Not required. All of this is all too much hallucination. I mean, it's all good stuff, but nothing to require. So int x, right? Int y. I mean, what could be simpler than this, right? I do need a semicolon here, right? So that's all. So this means I can start using it, right? In my program, right? Now I can use it. Yeah. Well, that's a good thing to do later. But for now, let's use the point inside our main, right? So int main, right? On. So how do we use it? I just type point, right? Point p1 or whatever, right? Yeah. And of course, okay. So the question actually, what are those coordinates? Are they guaranteed to be 0? Actually, right? That we'll see about the documentation. You have to look up. If I had to, if somebody was holding a gun to my head, I think they are all zeros. But don't quote me on that, right? So let's take a look, right? So we get to our friend dot operator, right? So, right. So, right on. So accessors, right? And let's print, right? Right. So very simple, right? So, yeah. So we use point template, yeah. Very similar to how classes. Yeah, very similar, right? In fact, it's in. So, structure, we define the data types, what we want inside. I think pretty simple, right? In the code. Success. X is success. X is success. X is success. Okay. This is type def, right? Define X success. All right. All right. So let's run it. So I don't think there's not going to be anything crazy here. Struct, CPP, right? And output struct. Compiles. Still hard to make a mistake in this, but you never know, right? So dot operator, right? So if you have the actual structure, right, you get the you can use dot operator to access. So again, so the main idea if I would use this is to, of course, to organize your data to combine related data, right? So for now each point, X and Y, of course, it comes to territory. Yes, you could store them separately, right? Just in arrays, right? But it's much more logical to store them together, right? And of course, we will get to maybe more complex structures, right? This is like your building block, your starting sort of like your structure for your structure, so to say, right? Your building block. So everybody should be able to make your own data structures now. I think not too hard, right? And again, so here is a big house definition. This has a string, how many bedrooms, how many bathrooms, how many cars, and so on and so on. Has double price and tax, right? And then you should start printing these structures, right? And again, I want to see if you get zeros. Okay, yeah. So notice here, right, how actually happens in the memory, right? When you actually make an instance of this structure, right? When you make this data type, use it. That, well, you need the memory allocated for this, right? And actually, of course, there are some alignment issues, meaning some memory might not be used completely, actually, right? Sometimes you have some room, there might be some unused space. It's for memory alignment issues. But that, again, nothing to be worried about at the moment, right? So what else? So yeah, syntax is called member access operator, right? Again, it's just dot, right? Used by, I think, most languages. If you have some sort of OOP, right, which will be used as dot, right? So, again, dot, right? Dot access, right? Here, dot access, that's a comma, right? I mean, that's a Latvian comma, right? So let's make a player. Right? So let's make a player. Let's make a, for now. So let's make a player struct, right? Yeah. String name, health, score, right? What else could we want? Maybe location, right? Well, let's make something more interesting now. We could also place the player locate position here, right? And now the question is now, so what could we do? We could do x, y, right? Integer, let's say float. In fact, x and y coordinates probably should not be integers, probably should be double, right? Otherwise you have this discrete, right? So what should we do? Well, is assuming if this is part of some game, right? Point and player, right? You probably want the player to be point, right? No, we will do. So we will, we could use x and y, but better would be to use point, which we already made, all right? So we could build on this, right? Point position, right? Or pose, I would say pose, but okay, position, right? Position of the player, again. So again, you get nice descriptive names, right? So this is our data structure using already another data structure which we already defined. Okay? Now, so I'll refactor this so that control, so the double, right? This should be double, really. I don't know why I double, right? Well, I mean, as long as you made it discrete, right? So, and that's another beauty. If I decide to change the structure here, of course, I don't have to change it here. It's still a point, right? So, okay. Now we have player. Let's make a player, right? So now, let's create a new player. Let's create a player. Valdis, right? Well, player one, but print. Yeah, print. Well, now of course, printing a player, right? We have two options actually here. We'll talk about classes, right? We'd like to print all the attributes, basically, all the data inside, right? How would we do this? Well, we could do it separately. We could make a let's create a function that prints a point. Okay, void print point p, right? So okay, this is of course a side effect, classical side effect, right? Classical function with classical side effect printing to console, right? For utilities, similarly, let's create a function that prints a player, right? Again, so you say what are you passing, right? Again, you won't be able to modify this player, right? Let's think about this. Okay, so print. So also, I like this. That we are again print player position, right? All right. So this, of course, not as nice, but okay. Point has a score, right? Now we have print player function, and let's see if it works. Actually, what we'll get here, I don't know. Print, yeah. So let's print player. Yeah. Big question is what will happen? What will happen here? Yeah. So let's think about it, right? So, or you don't even have to think about it. Let's just have to see what's going to happen, right? Whoa. So player has no name, but health is negative 13 something, 130 million. Score is 32 something. Okay. So the answer is garbage, right? So we are getting garbage. So we got garbage because. So we got garbage. Values so because I like those now. Yes. All right. Let's initialize the player Valdis. Right. Then well, right. Health 100. Okay. Score 0. Position P1. Yeah, that works. By the way, this does work. It's possible to do that. Yeah. Or we could create a new point. Well, new point. Point. Well, right. So this should work basically, right? In this case, since this is really simple, the point structure is really simple, xy, right? So I'll put some coordinates. Maybe like I'm like I don't know. 7, 7, right, and like, I don't know, 32 point something, I don't know, right, okay, so this should work, right, because doubles, fine, right, now it should work, all right, now I can print it, and of course, it should work, all right. Alright, Valdis health score, right, point has x and 7, and y has 32.56. Okay, so it looks okay. Could we initialize them? Let's make another player. SpongeBob? No.
Yes.
Player. Okay. We. How about SpongeBob? Right, SpongeBob. Wow, he gets more health than me. That's not fair. Okay, so player. But question is, let's initialize at the time of creation. Player SpongeBob 200 100.00, right? So, and again, notice how we do this recursive. I mean, structure inside structure. Again, note again how we create a point inside the player. Of course, so you can think of this anonymous point. Of course, since it's given to the player 2, right? We do have a reference, right? So it's not forgot. It's not gone unforgotten, right? So now, of course, SpongeBob. Let's print SpongeBob, right? And now we can print player, right? And you should see the values, right? And this is actually, I am using the C++ structure more like C-type structure. What do I mean by that? I mean because I am not actually doing anything with the I'm just using structure for data, right? Or they're saying plain old POD, plain old data, POD, right? So I'm just storing it using functions outside. So, right. So again, note again side note. So note these functions take the structure's arguments. This is similar to how I would have done this in regular C language, right? C++ offers also member function, but those are for later when we talk classes, right? So that's another side note, right? So print. Okay, I don't know what else. What kind of fun things could we make this player do? Jump and so on. Of course, once we get into doing something, right, we'll probably kind of want to do the member functions, right? That's probably for next lecture or lecture after that, right? So, okay, we can print the players. Let's see what the book says. What else do we need to learn, right? So yeah, so that's something interesting. So this part is kind of a little bit. Might be a little surprising, right? But let's double check. So this is not, most language like Python, for example, doesn't have this, right? Does not have this behavior. So this means that the content will be copied, right? Not just references, just the actual content. So let's see, right? So let's do Squidward, right? But let's do, let's copy player 2 to 3, player 3. So player 3, right? All the values, right? Right? C name. Let's print just the name. Right. So you'll see this is going to be still SpongeBob, right? Yeah. Now let's change the name to Squidward. Well, Patrick would be good too, but Squidward, right? Right? On. Yeah. So this behavior is different from say Python, where copy. So this is part here, right? This is a little bit, again, one of those, again, food guns, potential food guns, right? I mean, it's useful. This is a useful behavior, right? But actually, again, we are actually copying the whole structure completely. So let's take a look if this is actually the case, right? So we copied, right? Or we can print both players, right? I guess we can just print. Let's print. Okay. Let's print both players, right? Okay, let's do this. All right, let's take a look. So yeah, so you can see here already. Right, so the player 3 got named SpongeBob, right? Player 3 now is Squidward, and of course now again player 2 is still SpongeBob, right? So this actually was a full copy. And again, points too. Actually, I guess let's compare. Let's change some points as well, right? Let's change some points to make sure is this really true. So because also is the full copy or is it deep copy or shallow copy, right? Good question too. So now let's change coordinates of player 3, right? So how would that work? What do you think? Well, we have position, right? And position has what? Position has x and y. So we use the dot, and so on, right? Very common in OP languages, right? C# or in pretty much any language, Java, of course. Well, yeah, you have this dot, right? So we could use this, but I think, no, that's a good question. So player 3 position x. This is a good point to check. Is this shallow or right, or not really? 205.5. Let's take a look. Is this really going to change things? So we got 200, SpongeBob was 200. No, 00, right? Let's take a look. Is this actually going to copy? Will it change player 2? That's the question. Again, empirical testing, right? Of course, you could go look up in a book, but let's double check. It's allowed. I didn't break anything. Yeah. So Squidward is at the x and 205.5. SpongeBob is x and 0. So answer is that. So actually the Yeah, yeah. So we copied everything. So it has values all the way down. Again, and possibly again there might be some limitations to this approach. I mean, how far does this copy go, right? But in this case, it looks like it was actually full copy, right? So note again, note or yeah, yeah. We use double dot notation, right? So again, another thing, of course, why this dot is so popular, if you have normal IDE, it will pick up on the properties, attributes, and so on, right? You don't have to think. Again, just imagine if you, for all different data structures, you have to think about what's available, what's possible, right? Like here, of course, I don't need AI or anything, right? I have my ability, if I do something like this, player 3, right, dot, you see, I have health, name, position, score, right? And if I put position, I have a dot, I have X and Y, right? And this is from Visual Studio Code, pretty much any normal C++ editor, you know, which has support for C++ structures will pick up on this, again, because of the static definitions, right? So very, very nice. Okay. All right, so let's see what does the book want to tell us more. It's, well, only 22 slides, so this looks like there's not much today for as far as slides. And of course, right, so this is like copy, right? Yeah. But however, do we want to, if you want to compare, right, then, well, I don't think so. It's not built in. So comparing, right? Comparing two structures, right? I don't think you can compare them separately. Well, I mean, you can. You can make your own equality operator, but I don't think it's not built in. So let's look at the C++ reference struct, right? And what does it say? Struct declaration, right? Maybe we missed something here. So. Allocate in ordered sequence, right? Ordered sequence, right? All right, you pick up anything, right? Double D, flexible array member, right? Of course, things will get interesting with arrays, right? Well, of course, we are not talking about unions. Unions, something completely different. Well, so structures. So, okay, because members of incomplete type are not allowed, a structure is not complete until end of definition. A structure cannot have a member of its own type. So you cannot have a player who has a player inside the player, basically. Of course, what's the important point, we'll get to pointers, we make linked lists and things like that, and trees, of course, then that is allowed, right? So here's an example. Let's take an example, right? So yeah, so you have a car, right? Yeah, of course, this is using C type of string. Usually, of course, I would recommend you make a regular string. This is going back too much into this regular old C type of strings, which are not really recommended, right? Spaceship, right? X-wing, starfighter, so on and so on and so on, right? So we don't want these offsets, right? Okay, structure initialization. Let's look more about this initialization set, right? So yeah. So there are different ways of doing it. We can use equality, right? Non-empty, brace enclosed, comma, separate list, initialize for the members. So structure, we can use this. This I think since, I don't know when did they added this. Let's make a player with initialization, full initialization. Yeah, now let's make one more player. This example, right? S. Let's make another player. This is going to be probably Patrick. Another player, Patrick. Let's use syntax to initialize. So player. Well, no, not well. Actually, yeah, this is fine. Of course, I think we can do this. We can do some fancy stuff. I think this is allowed, but I'm not 100% sure. So point name, right? Yeah, this approach. So you can do this. So this is kind of similar how in Python, you have name parameters, right? So you can use this approach as well, right? So alternative approach to initialization. Score, position, right? And of course here again, I could switch, but yeah, I'm using name parameters, right? I'm using, if I use name. Okay, so let's try this. So again, see if this is going to compile. Again, big question. Is this going to compile? And maybe, point y equals 10, right? And point x equals 10. So again, positions are switched. Right. Now, let's take a look, right? So nested, so this is a more complex example, right? Again, of course, in real life, right? You should not, without. I don't know why would you want, right? Yeah, but it is possible. Again, right? So, and of course, we could sometimes skip. I mean, of course, where could this be useful? This could be useful. It could be used to skip initializing some values. You have a lot of them, right? You don't need to. Maybe for some reason you have all this data later on, but you don't want to initialize everything immediately. Let's print this player. Let's see what happens with Patrick. Yeah, you should see if this works, right? So this reverse order, to show you that it's possible. To show that it's possible. Okay, let's compile this. Okay, so maybe, I messed up somewhere. Okay, curly braces. This part here might be slightly, I think, do you need semicolon here? Maybe. I think so, maybe. No, that's not good. So this part here, yeah, I think, maybe I need this point. Yeah, I think this one's okay. Yeah, equals point. I don't know if this works. Let's try this again. So this, because we're doing nested initialization. Nope, still not. So how would we do this? Because maybe we need to, we need to pass it. Can I do this? I don't know if we can do this. Now, maybe. I don't know. This looks a little bit iffy, slightly suspicious. I don't know. I'm trying to do things which maybe I shouldn't. Oh, okay, yeah. So again, maybe I need to make the point. Basically, I'm trying to make a point on the run. I guess I shouldn't really do this. Again, maybe you can, but again, AI again. So here, of course, I could have. Okay, there's extra semicolon. What's okay? Okay, now it should work. Let's try it one more time. Oh, wow. So, position equals point. How do we make points again before? Oh no, this was okay. Point, this was legal. Oh yeah, curly braces. Curly braces. All right, yeah, so again, don't have to remember all this, but all right, again, maybe, okay, so maybe declaration, it's not possible actually. Okay, so it's actually complaining about this, what I was trying to do. Okay, maybe I shouldn't do this then. The doctor hurts when I raise my arm, right? Then you shouldn't raise your arm, right? Right, this hurts when I do this, don't do this, right? So don't do this again, trying to break things. So now I guess it should compile. I thought you could switch around. Maybe I'm wrong, I guess. Yeah, it works fine, but I guess you can't really switch the values. But again, not really, thought there was a way to do this, but LTK, right? Yeah, left curly brace, left open brace. Yeah, there is. Yeah, but again, hopefully again, all these extra syntax additions, they're not really not the main thing. Main thing for you to remember from today's lecture, of course, is how to make your own basic types like these, right? Structure, right? Or even this one here, right? To do some extra additions, maybe is not required, right? Usually you just do regular initialization, right? Like this, or of course like this, right? This thing's pretty simple to follow. But again, the named ones, of course, are nice. It just tells you maybe slightly more readable, right? Yeah, yeah, okay. So the question: what happens if I skip the point? Yeah, yeah, all right, all right. Positions are not switched, so don't. All right. Now, a couple more minutes. What the book says else, right? So comparing, right? So now, how could we compare our players, right? Yeah, right. Yeah. I mean that's possible, right? But how about whole structure? Well, this should not work, right? Because it's, you see, there is no definition. AI thinks there is, but it's not going to work, right? Okay, let's first compile this. Yes, but how about this one? Right, so it's basically, turns out it's not defined. Right, let's try compiling it. I don't think it works. Yep, you see, there is no comparison function, right, operator. So basically this means you have to do it yourself, right? Again, so it's kind of interesting that this copy is provided for you, but comparison, well, you have to figure out yourself, right? There is actually a way of making it, right? But we're not going to do it in this lecture. But we can, of course, make a special comparison, right? This won't work, not provided, right? This is not built in, but you could, yeah. So we will do a function to compare the values after the break. All right, so pretty simple stuff right now. Let's take a break for about 15 minutes till 12:05.